Okay, physics fans, welcome back. Or what's that? We're working on the projectile packets for Physics 11, and we're doing question number 11. This is what brings you here. This is going to be one of the harder ones so far. A pilot cuts loose of 2 fuel tanks in an effort to gain altitude. At the time of release, the plane was 120 meters above the ground with a speed of 84 meters per second. For how long did the tanks fall? That's the time. Also determine the vertical speed when they hit the ground. What's the horizontal speed when they were hitting the ground? And what is the total velocity of impact? Very unique question. Okay, let's take a look at this. So the packages right here, I'll highlight them yellow, there we go, boom, are traveling at 84 meters per second horizontally, 120 meters above the ground when they were released. So let's start filling in some of the blanks. The horizontal speed is 84 meters per second. The vertical distance is 120 meters. This is 9.8 meters per second squared, and both of those are down. It does say that they are going horizontally. It was 120 meters above the ground with a speed of 84. So we're assuming they're traveling at 84 horizontally. So 0 here. And if that's the case, again, let's just show you one more time. D equals VIT plus 1/2 AT squared. This is 0. And because that is 0, we can now use this without having to do a quadratic equation. I mean, using the quadratic formula to solve for it. Rearranging it, we get T is equal to the square root of 2D over A. Now, realistically, it's plus or minus, but we're not going to have a negative time. You can't land seconds before you let go of it. 2 times 120 divided by 9.8. And you get the square root of 2 times 120 divided by 9.8. And we get almost 5 seconds. 4.9487. So 9. Actually, I'll write down 87. 4.9487. 4.9487. Now, normally I would calculate this. That's what we've been doing. It doesn't even ask for that. We don't even need that in this question. But we did answer that. The time is 4.9487 seconds. Now it says determine the vertical speed. So this is the vertical speed at impact. So we can solve that without time as VF squared equals VI squared plus 2AD. And that's not using the time. Or if we wanted to use the time, VF is equal to VI plus AT. So we just take 9.8 times the time, and that'll be VF. So I'll do it that way. Take this and multiply it by 9.8. And I get a final speed of 48.497 meters per second. But I could have done it 2AD and then square root it. So 2 times 9.8 times D and then all square rooted. Let's try that. The square root of 2 times 9.8 times 120, and that should be the same number. Write down. So that's the vertical speed of impact. What is the final horizontal speed? That's what's asked for here, the horizontal speed. The horizontal speed doesn't change. So the final speed horizontally, (84 meters per second). What's the total velocity of impact? To calculate that, well, at least to understand it, let's just take a look at this. This is PhET's projectile motion website, little tutorial. And if I clear it up and fire it, we can see what actually happens here. And fire it to so the projectile is moving here and it's fired horizontally here. Let's just analyze what happens again. Just fire it. So initially, the velocity vector here is 11, and it stays 11. And when it started, we didn't pause it right away. There was no downward arrow. Then the downward arrow here starts getting bigger and bigger. So I'll just step forward and we can see it. The downward arrow is getting bigger and bigger, and now it's about 11 as well. 11 that way, and 11 that way. And we keep on doing it, and so that's has the constant horizontal and constant vertical, but really it's actually moving in this path in one dimension, and in 2 dimensions. So let's see the 2-dimensional vector. So I'll say, let's see the total, and we'll fire it. There it is. It's fired horizontally that way, and as it moves, it's doing that. Let's take a look at the component. It has this much to the right, and we can see it. I'll leave the mouse cursor there. Maybe I can't leave the mouse cursor there. I'll leave the tape measure there to the right, the little plus sign, and I see the total. It still has that total to the right. And then the component of the down, let's put the start there, and the down. When I go to the total, it also has that much down. So that's the total velocity. That's the vector that we want. Well, at impact, so we'll just keep on plugging along, and just before impact I should have paused it. You would have the 11 still to the right here, and this one would have a huge one down, and that's what we're trying to get. So let's go back to OneNote. Here we go. So the total velocity, let's just reiterate that. It is moving at 84 this way, and vertically it lands at 48 down. So to add them, 48.497 down. So we start there and we add them by tail to head, then tail to head. And let's draw what that final vector is going to look like. That's it. So that green arrow is what we have to describe. How do we calculate that? Well, it's a right-angled triangle because horizontal and vertical are at right angles. So we can use Pythagoras to get the length of that. I'll call it Pythag, and that will be the hypotenuse, which is the final velocity, and it's the vertical. And to calculate it, we have to square both. So it's going to be c² = a² plus b², but I don't want c squared, I just want c, so I have to square root both sides. So I have to take 84 squared plus 48.497 squared and square root it. And in the calculator, we go square root of 84 squared plus that number above squared equals, the hypotenuse length is 99.9948, eh? 96.9948. Whew. I'm keeping a lot of numbers there. Probably shouldn't, but that's the way I'll do it right now. But that is only telling me the length of that. I now need the direction. I need the direction. I need this angle, because that'll tell me how far below the horizontal it is going. I need that angle. Because as it is a vector, I need the magnitude, meters per second, but I also need the direction. So how do I get that angle? Well, we have to use some trig and the tan of that angle. So katoa, opposite and adjacent. This is the opposite of that angle, and this is the adjacent of that angle. And the tan of that angle is equal to the opposite over the adjacent. So we have to take the inverse tan to get the angle. So the tan of theta is equal to 48.497 divided by 84. And now I have to go tan, inverse tan. So we'll pull it up. Second tan of 48.497 divided by 84. And that gives me, 30 degrees. Hey, that's pretty cool. And that is 29.9998 degrees. So how do I label all this? How do I put it together as one complete answer? Because we have two numbers to put it down there. We write down that the final vector velocity is, and I'll just do this to 97 meters per second. Now with square brackets, now I put the angle, which is 30 degrees. I'll put 30.0 degrees. And this is below the horizontal, below the horizon. So below the horizontal. And that's the answer. That's a complete vector. That's the final vertical velocity. Final velocity. The final vertical velocity is 48, the final horizontal velocity is 84, but the final velocity is 97 at 30 degrees below the horizontal. Dun, da, da, da. Remember, subscribe, like, comment below, and start honing up on some of our trig skills, because that's what's coming up soon, right away actually. There's the TOA, SOHCAHTOA. Thank you. Enjoy.